Hey everyone, and welcome. Today we are really digging into a huge shift in networking, Cisco's SD-WAN cloud on-ramp for colocation. We're going to see how this isn't just some small upgrade, but a whole new way of thinking about how big companies should connect to the multi-cloud world, tackling those massive headaches of latency and cost.
So here's how we're going to break it all down. First, we have to talk about the problem, why modern networks are under so much pressure. Then we'll introduce the cloud on-ramp solution and, pop the hood to see how it's all put together. After that, we'll walk through what a deployment actually looks like. And finally, wrap up with how you manage and scale this whole thing day to day.
Okay, so before we jump into the shiny new solution, we've got to be super clear about the problem it's trying to solve. I mean, the traditional network designs we've used for years were great, but in a world that completely runs on the cloud, why are they suddenly falling so short? This slide just lays it out perfectly. Look over on the left, that's the classic backhauled model. All your traffic from every branch office, even if it's going to a cloud app right next door, has to take this long, slow trip all the way back to the main data center. So people tried fixing that with distributed access in the middle, but that often turned into a security and management mess. The real goal is what you see on the right, optimized access. It's that smart middle ground, using regional hubs to give you the best of both worlds. And this right here, this quote just nails why that old backhauling model is so broken. It creates this thing engineers call the trombone effect. Traffic goes all the way into the data center, makes a U-turn, and goes right back out. It's just a totally pointless detour that adds a ton of latency, chews up your expensive private bandwidth, and honestly, just creates a horrible experience for anyone trying to get work done on cloud apps. All right, so if that's the problem, how do we actually get to that optimized access nirvana? Well, that is exactly where Cisco's cloud on-ramp for colocation comes into the picture. The basic idea is actually pretty simple, but it's incredibly powerful. Instead of dragging every single bit of traffic back to your main data center, you build these smaller, super automated network hubs inside colocation facilities. And these aren't just any buildings. They're strategically located right at the crossroads of the internet, putting you physically closer to your users and, crucially, to the major cloud providers. You're basically building a high-speed, secure on-ramp directly to the services your business relies on. And when you make this architectural shift, the benefits just start rolling in. Because you're closer to your users, apps just feel faster, and hitting your SLAs becomes way easier. Security isn't a bottleneck anymore because it's distributed. And the big one for the business, you start slashing those expensive private circuit costs by using more efficient internet paths. The best part? You manage all of it from one central place. This diagram really ties it all together. You've got traffic coming in from everywhere. A branch office, a business partner, maybe a company you just acquired. SD-WAN policy intelligently steers that traffic to the right regional hub. Once it gets there, it gets pushed through a specific service chain that you defined, like, say, through a virtual firewall, then through an intrusion prevention system, before it's sent on its way. It's policy-driven control at a whole new level. Okay, so we know what it does and why it's so great. Now let's do the fun part. Let's pop the hood and really look at the building blocks, the architectural pieces that make all of this magic happen. Whoa, okay. I know this diagram looks a little intimidating, but let's just break it down. Think of it like a company org chart. Up at the very top, you've got Cisco vManage. That's the CEO of the whole operation, setting the high-level vision. Reporting to vManage is the Cisco Colo Manager. That's kind of like the on-site plant manager, handling the day-to-day operations of the hardware. And then you have the workers on the floor. The Catalyst switches are the physical network, and the Cisco CSPs are the powerful servers that are actually running your virtual firewalls, routers, and all that good stuff. Let's put that in even simpler terms. The Cisco CSP, or Compute Service Platform, that's just the physical server, the metal box with the processors and memory. NFVIS is like the special operating system that runs on that box, letting you host a bunch of virtual machines. And the VNFs, or virtual network functions, those are the virtual machines, the software versions of your firewalls and routers. The network fabric connects it all, and Colo Manager and vManage are the brains of the whole operation. You know, high availability is just absolutely baked into every single layer of this design. The whole point is to get rid of any single point of failure. You've got redundant physical switches. The compute servers are constantly being monitored, ready to fail over services. The virtualization layer has its own health checks. Your individual virtual services can be deployed in redundant pairs. And get this, even the local management software is designed to recover itself automatically. It is built to survive.
All right, so with that architecture in our heads, let's walk through what it actually takes to get one of these colocation clusters up and running using Cisco vManage. So everything starts with the physical gear. A basic starter cluster kicks off with a pair of Catalyst 9500 switches for network redundancy, and at least 2 Cisco CSP compute platforms for service redundancy. This stack of hardware creates this amazing, resilient pool of resources that vManage can then tap into to spin up all your virtual services. Now hold on. Before all the automation magic can kick in, you've got to do a little bit of homework. You need the right hardware racked up, the right software versions running on everything, and the right licenses, of course. But, and this is critical, on the networking side, you absolutely need a DHCP server configured with something called Option 43. This is the secret sauce that lets the hardware automatically phone home to its vManage controller, making that whole zero-touch provisioning dream a reality. So, once all your prep work is done, the first big step inside vManage is to define your cluster. You're basically building a digital twin of the physical gear you just racked. You graphically show vManage. Here are my switches, and here are my compute servers. This process registers all those physical resources and makes them available as one giant pool for the orchestrator to play with. Okay, now for the really cool part. Once that cluster is defined, you start creating what are called service groups and designing your service chains. And this interface is it's incredible. You literally drag and drop icons for your routers, your firewalls, whatever you need onto a canvas, and then draw lines to connect them in the exact order you want traffic to flow. This completely changes the game, turning what used to be a complex CLI nightmare into a simple, visual, automated process. And this is the end result. This is what it's all for. Once your service chains are live, you just use policies in your SDWAN fabric to steer the right traffic to them. So in this example, traffic comes in from a remote site and it hits that colocation edge router. A data policy sees that traffic and says, aha, you need to be redirected through the service chain we just built. First the firewall, then the IDS IPS, before it can continue to the public cloud. You get this incredibly precise, policy-based control over your entire traffic flow. Okay, last but not least, let's talk about the day 2 stuff. How do you actually manage this solution? And maybe more importantly, how do you scale it to handle multiple customers or different departments inside your own company? Well, your day-to-day life is going to be spent right here, inside vManage. This dashboard gives you this super detailed port-level view of the entire cluster's health. You can see the status of every switch, every server, every physical link, all in one place. It lets you troubleshoot everything from a bad cable to a struggling virtual machine, all from that one true single pane of glass for your entire edge. Now, for any service providers out there, or even really large enterprises, multi-tenancy is an absolute game changer. It means you can take one big, expensive physical cluster and securely slice it up to serve lots of different customers or departments. This just dramatically improves your return on investment because you're sharing the hardware, but each tenant is living in their own logically isolated, totally secure world. And bringing on a new tenant is this simple, repeatable workflow. You create a new group for them, you define their permissions using role-based access control, which is really just a fancy way of saying you decide what buttons they're allowed to click, and then you add their users. It creates this really secure, scalable model for growing your services without everything turning into chaos. So to wrap it all up, Cisco's Cloud OnRamp for colocation is a direct response to the performance and cost problems we've been struggling with for years. By taking all those network and security functions, virtualizing them, and moving them out to the edge, closer to your people and closer to your clouds, it builds a much faster, safer, and cheaper bridge to this modern multi-cloud world we're all living in. And really, this whole shift away from a centralized data center to a distributed edge, it's more than just a tech refresh. It's a fundamental strategic change, and it leaves every network architect out there with a really important question to think about. As applications and intelligence keep moving out to the edge, how are you going to reshape your security and cloud strategy to keep up?